Thank you, Jim. Hi, everyone. I'm Cindy Xiong, Assistant Professor at UMass Amherst College of Information and Computer Sciences. And the key message I want you all to take home today is that you have a lot of power when you communicate data to other people. Well-designed data visualizations can lead to powerful and intuitive insights, but poorly chosen visualizations can leave important patterns obscured and misunderstood. Let's look at an example. So here we have a chart depicting the number of COVID-19 cases reported over 2 weeks in 5 counties in Georgia. Let's take a moment to look at this. The first thing you might notice is that there is a downward trend in cases. They're getting better. But after taking a closer look, you realize that is not the case. The x-axis values are sorted by size, not by time, so the downward trend is misleading. So the Department of Health in Georgia intended for this visualization to help you notice which day had the most number of cases and which day had the least number of cases. But it wasn't very effective because it's so intuitive for us to notice this downward trend. You could alternatively show the same data via a different design, sorting the data by county, and the x-axis is ordered by time. Now the pattern that stands out to you is how the number of cases change over time for these 5 counties. It's clear that there is a bimodal distribution of cases over time, but it's difficult to determine on which day there was the highest versus the lowest number of cases combined. So what we see here is that these two designs make you see very different patterns in the same data set. So it seems easy to critique the visualization and identify problems in hindsight. Designing a visualization is very complicated. And here's how it typically works. So first, researchers need to collect the data, and data scientists to analyze data and generate insights from data based on what the researchers collected. And then they design visualizations and interactions before the visualization can reach the end user, or we call the information consumer. And this process in reality looks more like this because designing a visualization involves a series of design decisions, and each design decision can afford different interpretations. So what I've spent the past 6 years researching on is the space of how design decisions map to viewer interpretations. Imagine this model where, given a design, we can predict how people will react to a visualization. And this space could look like this, or it could be like this. And this design space is quite enormous. Since we have limited time today, let's look at some examples. So here we have a visualization showing the durability of 3 components in 2 vehicles, A and B. What is the most intuitive comparison you might make here? Let's think about that for a couple of seconds. Feel free to mumble an answer to yourself. All right, so 80% of you are probably thinking, I want to compare vehicle A's component 2 and vehicle B's component 2. And I realize that vehicle A's component 2 is more durable than that of B, but the other components are less durable. Fair? All right, so let's look at this other visualization. Very similar stuff. The durability of 3 components in 2 vehicles A and B. What is the most intuitive comparison you might want to make here? Let's again think about it for a few seconds. Feel free to mumble it to yourself. So you're probably thinking, I want to compare the overall durability of A to the overall durability of B. And I want to come up with a takeaway that vehicle A and B are about equally durable. So although these two charts show the exact same data, the way I arranged the data visualization makes you do different comparisons, right? So this is just one example showing that the design choice can change what people compare in data. And in this case study, we see that people gravitate towards comparing things that are aligned. And when that doesn't work, they resort to forming visual groups and comparing these groups. So design choices can also be the type of chart you choose. So looking at this bar chart, it shows the revenue on the y-axis of two companies, A and B. and their two branches, east and west. When looking at this bar chart, the most intuitive thing people do is to compare magnitudes. You compare company A's revenue to that of B and see that A is higher overall. When I show you the same data using a pie chart, you begin to think about proportions. You notice that A West is the largest slice of pie. When looking at the same data now via a line chart, you think about trends and relative changes, noticing that the change in revenue from west to east is bigger in A than B. Scatter plots, on the other hand, are good at showing distributions and outliers. So here we have some Y value and how it changes over time. And people looking at this chart are thinking there's something wrong with that outlier at time 8. And heat map makes people cluster values together and realize the higher values are on the left and the lower values on the right. And people like to focus on specific numbers and their ratio relations when it comes to tables. So you want to say something like the value at time 1 is 6 times compared to the one at the time 10. So we saw some examples of how design choices can change what people compare in your data. Design choices can also change people's gut reaction towards data. So first, a little bit of background. We have two systems that help us make decisions. One system, the rational system, relies on logical analysis to make decisions slowly. Another system, the gut system, relies on intuitions to make faster decisions. Let's see them in action. Looking at this chart showing the number of accidents drivers are involved in, what would you conclude? It's tempting to say, well, drivers who use the new safety GPS system get in fewer accidents than people who don't. It looks like the safety GPS system causes people to get in fewer accidents. And this is your gut system at work, coming to conclusions intuitively and assuming causal relations when none is depicted. Now, having thought about it a little bit more, you've probably realized by now that maybe there is a third variable at work. People who choose to use the safety system may drive more safely to begin with, right? Now, this is your rational system at work, but it's very slow. And this bar chart triggers this immediate gut reaction to draw causal conclusions. So what if we take the same data and visualizing it using a line chart? Looking at this, your knee-jerk reaction likely is people who use the safety system tend to get in fewer accidents. With this line chart visualization design, the gut reaction triggered is not a misguided causal conclusion, but a correlational one. We can compare it to the bar graph and see that visualization design can trigger different reactions when we reason with data. So last but not least, design choices can also change the decisions people make with data. So looking at this chart, which shows the student government election voting results for two parties, blue and green, over the past 3 years. The y-axis shows the percentage support they received. Now, who do you think will win in year 4? Maybe take a moment to make a decision. I'll wait a couple of seconds. You may think that blue is probably going to win because you saw that blue has won every year or that blue has won most recently. Alternatively, you may think that green wins because green seems to be gaining momentum and is slowly closing the gap between itself and blue. So what I did is I carefully designed this visualization to make either outcome seemingly likely. So there's no correct answer here. So when I surveyed hundreds of people online about this, it turns out that they are evenly split. Half of the people predict that the green will win, and the other half predict the blue will win. But when I convert the same information into a table, you can see that the number matches the height of the bars, so the table and the bar charts are informationally equivalent. Suddenly, everyone thinks that blue is going to win because the pattern of the green increasing over the past 3 years becomes less noticeable when they're presented as numbers in a table. So hopefully I've convinced you that designing a visualization is complicated. It involves a series of design decisions, and each design decision can afford a different interpretation. Design choices can change what people compare in your data, it can change people's gut reaction towards data, and it can change the decisions people make with data. And design choices can cover an enormous space, so the mapping actually looks more like this, with many opportunities for us to explore the most effective way to tell our story. So it's important for us to iterate on our designs until we reach the best one. So let's walk through some high-level design techniques for better data storytelling. So here's a design. What do you think I'm trying to say with it? You're not wrong if you're confused. This chart looks quite like a spaghetti. There's just too much going on. So what should we do to fix it? What about this? Looking at this, you might be thinking that people most likely get their news from TV and radio, and least likely from their friends. So what I did here is I decluttered the chart by taking away the excessive labels and grid lines so it looks more clean. And when looking at a clean chart, people focus on the extreme values, especially if they're up top. I can make my story stand out even more by doing this. Now, the key takeaway message that people are increasingly relying on the internet to get their news looks much more salient. So what I did is I highlighted the key trends. I focused the viewers using this highlight to make the main message stand out and becomes much more memorable. So how we arrived at these techniques, which we generally refer to as declutter and focus, is that we have showed thousands of real people visualizations and asked for their main takeaways based on what they say. And we extract generalizable rules to help us identify the mapping between visualization design and the takeaways. So what we're slowly building towards is a model that can help us design better visualizations by predicting what the viewer will take away upon looking at a visualization. So the designer can adjust the visualization to more clearly communicate some key messages. So let's look at one last example. So here is our first chart. Doesn't it feel overwhelming? It's hard to tell even what it's trying to say. But we can declutter it by removing the unmeaningful background and text colors. And now it's much easier to see that the chart is about the top 10 design concerns in car manufacturing. We can further focus by using annotations and highlighting. We focus the viewers and help them realize that most design concerns are noise related, such as those in tires and engines and those caused by wind. So hopefully I've convinced you that you have a lot of power when you communicate data to other people. Well-designed data visualizations can lead to powerful and intuitive insights, but poorly chosen visualizations can leave important patterns obscured and misunderstood. So design thoughtfully. That's all I have. Thank you all, and back to you, Jim.